Hi, I'm Ms. Cho, and in this video, we'll look at how to use polynomial identities to multiply polynomials more efficiently. Polynomial identities are basically statements, mathematical statements, where we have a polynomial on the left and a polynomial on the right. And we're just saying that the left-hand side is always equal to the right-hand side, no matter what you choose for A and B. There's four main kinds that we're talking about. The first is the square of a sum. This is where we add two things and then we take the square. The second is the difference of squares, where we have two perfect squares and we subtract in between them. The third is the sum of cubes, where we have two perfect cubes that we add together. And then the fourth is the difference of cubes, where we have two perfect cubes that we subtract. Let's take a look at how these are useful in multiplying. In our first example, we're asked to simplify 3x squared minus 5y to the fourth all squared. Now I could do this by multiplying it out. I just recopy it, say 3x squared minus 5y fourth, and then 3x squared minus 5y fourth. And then I could distribute or use the box method or use vertical multiplication, whatever you like. But by using these identities, we can take kind of a shortcut. And so the first thing we're going to do is to figure out which identity matches the problem. As I look on the list to my right, there's only one where I have a square on the outside, and that's the square of the sum. So this is going to be the one that I use. Once I figure out which identity I'm using, the second step is to rewrite it with parentheses. So I know that a plus b all squared is going to be equal to a squared plus 2ab plus b squared, which is equal to a squared. And then I'm going to leave parentheses where the a and b go so that I can fill it in later. And this way it keeps me organized, reminding that I have to square everything that's inside this whole parentheses. My third step is to ask, what is a and what is b? This example, it might feel tricky because we have a subtraction sign here and we need it to be addition, but I can just rewrite that by saying plus a negative, because subtraction is the same thing as adding a negative. So then now I can see clearly that my first term that I'm adding is a 3x squared. So my a is going to be 3x squared, and my b is the negative 5y to the fourth. And now that I know what my a and b are, I can just fill them in the appropriate spots. Once I've plugged in my a and b, then all I have to do is simplify. So 3x squared squared is the same as 3x squared times 3x squared, which is 3 times 3 is 9, and x squared times x squared is x to the fourth. 2 times 3x squared times negative 5y to the fourth is 2 times 3 is 6 times negative 5 is negative 30. And then I have an x squared and a y to the fourth. And then the same thing, negative 5y to the fourth times negative 5y to the fourth is going to be a positive 25y to the eighth. So this is my final answer, which you can also check by using, your distribution or whatever other methods, but in the end, you'll come out to the same thing without having to find all your terms. Let's try a second example. Here we're being asked to simplify 10x cubed plus 7y squared times 10x cubed minus 7y squared. So the first thing we want to do is to figure out which identity matches our problem. I see that we have the same things that are being added and subtracted, and so the one template that matches is my difference of squares. So this is going to be the one that I use. I'm going to rewrite this with parentheses. So a plus b times a minus b is equal to a squared minus b squared, which is equal to my a squared minus my b squared. Now that I've rewritten that, I just have to figure out what is a and what is b. So my first term is my a, the 10x cubed, and my second term, the part is my b, or 7y squared. And then now that I have my a and b, I can just put them into the right spots and then simplify. 10x cubed squared is 10x cubed times 10x cubed, which is 10 times 10, which is 100, and x cubed times x cubed, which is x to the sixth. And then 7y squared times 7y squared is 7 times 7, which is 49, and y squared times y squared is y to the fourth. So my final answer is 100x to the 6th minus 49y to the 4th.